Hi class, I have to stay with below the 15-minute mark because I had to get a special code for that last lesson, part 2. Now we're on part 3. I have to watch that timer. All right, so we just got through talking about where functions are positive or negative. So hopefully you've read that. We're going to go through what this means for examples 1 through, I guess it's all just example 1. So all students take calculus. Now that's something I did not go through yet. So let me go through that real fast. So what happens is when we determine which of the functions are positive in which of the quadrants, what happens is when we mark positive, and that's why we're marking positive and not negative or anything else. We mark positive because what's positive in the first quadrant are all the functions, and then positive in quadrant 2 are sine, and positive in quadrant 3 are tangent and its reciprocal. We just use the positive regular functions, not the rest of the functions. So we're not going to talk about reciprocal. We're just going to know that the reciprocal functions are positive as well, just because it's the same ratio, just reciprocated. So this is tangent, and quadrant 4, what's positive is the cosine. So if you remember that, then that might help you with your signs on any of those special ratios you're supposed to find. So all functions, trig functions, are positive in the first quadrant. Sine and its reciprocal cosecant are positive in the second quadrant. Tangent and the reciprocal cotangent are positive in the third quadrant. And cosine and its reciprocal are positive in the fourth quadrant. So we have all students take calculus as a way to remember what your positive and trig functions are in all of the quadrants. So with that, if you're looking at example 1, it says if tangent theta is greater than 0, which quadrants could the terminal side of theta lie? So if tangent theta is greater than 0 is the key. Tangent theta is greater than 0. So tangent theta is greater than 0 means that we're asking for one where tangent is positive. All right? And that's in quadrant 3. And I'm just going to explain really quickly. It's in 3 and 1, but tangent is where both x and y are positive or both x and y are negative. And that's here. We have a positive ratio of y to x. And here we have a positive ratio of y to x because they're both negative. So I just think of that when I determine it, and it's tangent theta is positive in quadrant 1 and quadrant 3. Okay. The next one is secant theta is less than 0, so that means secant theta is negative, and its reciprocal is what we really look at, is where cosine theta is negative. So what I think of cosine is x over r. R is positive, so I'm just dealing with where my x is negative, and that's second and third quadrant. Right? That's what I do. Okay, next up, if sine theta is greater than 0, which quadrants could the terminal side of theta lie? So that means sine theta greater than 0 is positive. So that means y over r is positive, which means y is positive. And when I think of that, I know that y is positive when you go up. So it's positive first and second quadrant. So I say quadrant 1 and quadrant 2. All right. And then here we have 2 conditions. Both the cosine needs to be negative and the cotangent theta needs to be positive, which means tangent needs to be positive. All right. Tangent positive, cosine negative. All right, so I like to just draw a little coordinate axis and think cosine's negative where my x is negative. So that means here and here would give me a negative x. And then tangent has to be positive, and tangent is positive here and here. So tangent's positive in those two quadrants, cosine's negative in these two quadrants. So this quadrant is the place that both conditions occur, where the cosine is negative and the tangent is positive. So that would just be quadrant 3. That's how I figure those out. I'll answer questions on it tomorrow. All right, next question. It says find sine theta where cosine theta is 12 over 13 and 3 pi over 2 is less than theta is less than 2 pi. So we have these two conditions that we have to be met. Now cosine is 12 over 13 means cosine is positive. So this means cosine theta is positive. Where is it positive? Where x is positive. X is positive in these two quadrants. So we've narrowed it down to these two quadrants. Now we don't know where that triangle is going to be other than it will be in these two quadrants. Then if 3 pi over 2 is less than theta is less than 2 pi, that means 3 pi over 2 is right here. And when theta is between those two, it's between 3 pi over 2 and 2 pi. So it has to be here in order for the second condition to be met. That between 270 and 360 or between 3 pi over 2 and 2 pi means it's right there. The cosine theta is 12 over 13 means x is 12, r is 13. Now when x is 12 and r is 13, then we still have to find y. And by the way, y is going to be negative because it moves downward from the x-axis. And this is Pythagorean theorem. So to find that third side, we take 13 squared and subtract 12 squared, right? Under the radical 13 squared minus 12 squared. So 13 squared minus 12 squared is 25, which means radical 25, which is 5. So that means this side is negative 5, right? And so that's how you find all your sides. And then from there, we know our angle is the one attached to the origin right there. Sine is what we're looking for. It's opposite over hypotenuse, or y over r, same thing. So y is negative 5, r is 13. So negative 5 over 13. Okay, and that's what our sine theta would be. All right, next one, example 2. Give the exact values for each trig function. Now, I'm going to show you how to do these my way, which I think is the best way. You have to memorize the very least of all the ways. So SOHCAHTOA is going to be really important here. All right, what I do is I draw a coordinate plane and I draw this angle. So 150. 150 is past 90, 60 more degrees, which is right there. Then I draw my reference triangle. So if that's 150 degrees, that means this angle right here, the one attached, which is important, is 30 degrees. Once I figure out what that angle is, I figure out all the sides of a 30, 60, 90 triangle. Across from 30 is 1, hypotenuse is 2, radius is radical 3. Then, from that angle, I do the sine. Opposite over hypotenuse is 1 over 2. And I'm done. That's how I do every single one. So I have about 6 minutes. Let's see how many I can do. Tangent 300. So I start here. I go past 270, another 30 degrees, and that's my terminal side. The reference angle, how much farther do I have to get to 360? 360 minus 300 is 60 degrees. So this is 60 degrees right there. That's what that angle is. So across, this one has to be 30. Across from the 30 is 1. Hypotenuse is 2. Long side is radical 3, but because we're going down, it's negative radical 3. So my sides are, let me write them in 1, so you can, oops, what happened? I thought I made that red. Okay, so 1, 2, and negative radical 3. So what is the tangent? The tangent's going to be y over x, so negative radical 3 over x, which is 1. All right, pretty easy. Next one, going to draw is negative 135. So I go counterclockwise 90 and then another 45. So that's going to be 45 right there, left over. This is 135, negative 135. So if I go negative 135, I have 45, 45, 90 triangle. And that means my sides are going to be 1, 1, radical 2, but they're negative, negative 1, because I go back and down. And then radical 2 is that side. And if I want the cosine, remember that's x over r. X is negative 1 over r, which is radical 2, which rationalizes to negative radical 2 over 2. All right. Then the next few, it's taking forever. It's a real light today. Must be a lot of teachers here making videos. All right, I think this is the end here. Let me just make sure. Okay. Oh, that's really weird. Huh. I still have quite a bit to do, don't I? Oh no, that's our... All right. 11 pi over 6. No, we got to do cotangent 315. So I lost my little bars, but that's all right. So 315, first I draw it. That means I go to 270 plus another 30 plus 15, 45. So that's a 45-degree angle. Draw my triangle, and I have a negative 1, 1, and radical 2 as my sides. All right, so cotangent is x over y. So x over y, oh, that's negative. So negative 1 over 1, which is negative 1. All right. Let's see the next one. Tangent negative 240. So I have to go counterclockwise. 240 is 180 plus 60. So 180 plus 60, that means that's a 60-degree angle. So that's 30. Across from the 30 is 1. Hypotenuse is 2. Radical 3. And my 1 is negative because it moves backward. So tangent is y over x. So y is radical 3 over x is negative 1, so makes negative radical 3. All right, secant 420. Now, first thing I'm going to do, because 420 is greater than 360, I have to subtract off 1 full revolution to get my actual terminal side. So that is 60 degrees more than 360. So I'm going to move a full revolution plus 60 more. Okay, that gives me a reference angle of 60 degrees right there. So this is 30. Cross from the 30 is 1. Cross from the 60 is radical 3. And hypotenuse is 2. All right. So the secant is, let's see, it's the reciprocal of cosine, so it's r over x. So r is 2, x is 1. So that one's going to be 2. The secant 420. All right, cosine 11 pi over 6. Now, these are a little tricky because we're traveling 11 parts of pi that are 6. So here's pi right here. So I have to break from here to here up into 6 parts. And then of those parts, I need to travel 11 of them. So I have 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11. Right there is 11 pi over 6. Now, 12 pi over 6 reduces to 2 pi. So this is just pi over 6 right there. Right? My reference angle is pi over 6, which 180 divided by 6 is 30. It's a 30-degree angle right there. So across from the 30 is 1, 2, radical 3. And that one's negative. So the cosine of that angle is going to be x over r So radical 3 over 2. Okay? Oh, crap. I went past 15 again. I'm going to stop it. I guess I'll